notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC that became effective in May-June 2018. As of January 2026, the syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to this exam is to split the exam into two parts. The current structure or format of the CSEC math examination, there is a paper 1 which runs for 1 hour and 30 minutes, and it consists of 60 multiple choice items from all sections of the syllabus as outlined here. Paper 2, which runs for 2 hours and 40 minutes. This paper consists of 10 compulsory structure type questions from all sections of the syllabus. Note the current exam structure for paper 2, no choice, all sections will be tested, as I said, with compulsory structure type questions. There is also a paper 031. If you are in school, you know that better as school-based assessment, SBA, where your teacher may either ask you to come up with this or give you certain suggestions to do research to obtain data, and then you would have to do some statistical analysis on that data. That is, if you are in school, you do paper 031. If you are writing this exam as a private candidate, then you would write 032, which is alternative to paper 031. And in this case, you will be given data and asked to do some statistical analysis on the data in the exam. Profiles. There are 3 profiles: knowledge, comprehension, and reasoning. In paper 1, you get 18 marks on knowledge, 24 marks on comprehension, and 18 marks more on reasoning, which is the 60 marks from the 60 multiple choice questions, and that will eventually make up 30% of your final grade. Paper 2, 30 marks from knowledge, 40 marks from comprehension, 30 marks from reasoning, 100 marks, which will eventually boil down to 50% of your final grade. And paper 3, you could follow the same pattern. Overall, the exam is 200 marks, which will be graded down to 100%, and that will determine your final grade. Schedule of videos, as you know by now, section 1, 2, and 3. All 51 of these videos have been published in their entirety on YouTube. From section 4, 5 of 17 videos have been published in their entirety on YouTube, the others partially published on YouTube. Section 5, statistics, 5 of 18 of these videos have been published on YouTube in their entirety, the others partially. Section 6, algebra, 7 out of 22 have been published in their entirety on YouTube, the others partially. Section 7, 9 of 26 videos have been published in their entirety on YouTube. Note that the others have been partially published on YouTube. Section 8, geometry, where we are now, this is the 14th of 24 videos from the section. And then, of course, after that, we'd have to do section 9, hopefully by August 2026. I keep pushing back this schedule. Disclaimer, this schedule is just a projection. and it is not to be interpreted as a contract with anybody. Going back to section 1, number theory and computation. I have divided that section into 33 videos, and as I said before, they are all published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. 33 videos. Make sure you look at all of them and know them very well. Reminder, if you plan to write this exam at CSEC, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Still on section 1, some of these videos, as a matter of fact, almost all of them, are applicable even in the primary schools for students who could look at them on their own, the older students, grades 4, 5, and 6. Teachers can use them in the inverted classroom, and especially for parents who forgot most of this work or never learned it, and they could get a lot of help here so that they could look at the video with their children and then ask the children to explain it back to them. For example, if I expand this blue section here, video 6, it says add, subtract, multiply, and divide whole numbers. That is work done in grade 3 in primary school, but remember, this is section 1 of the CSEC syllabus. And then video 7 says add, subtract, multiply, and divide decimals. That's work done in grade 4 in primary school. Video 8, add and subtract fractions, and video 9, multiply and divide fractions, work done in grade 5 and of course grade 6 and others. So most of this work from section 1 is actually primary school work. If you are looking at this video, you know that you are already at this channel, Arrow EL922. If you rearrange it in terms of playlists, you would see the different sections. The one that concerns us right now is section 1. Most, if not all, of section 1 is work done in primary school or work that should be done in primary school. It says CSEC Mathematics Section 1, Number Theory and Computation. Don't be misled by the title. It may sound a little scary. CSEC Mathematics Section 1, Number Theory and Computation. But I said that is work that should be done in primary school, the whole section. Section 2, Consumer Arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, Measurement. Now, some of these have been published on YouTube in their entirety, as shown by these yellow boxes here. The others are partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, Statistics. Again, these indicated in yellow here have been published on YouTube in their entirety. The others, partially. Please see directions in the description below for full access to these videos that are only partially published on YouTube. And that will apply to the other sections that follow. Section 6, Algebra. These 7 videos have been published on YouTube in their entirety, as indicated in yellow here, and the others partially. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 7, fairly difficult section, Relations, Functions, and Graphs. And these 9 videos have been published on YouTube in their entirety. The others, partially published. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2 to get especially more practice questions. CSEC recommends the following, shown at right here, these here. From those, I would recommend these last two here, as shown in the next slide, because they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of Volume 1, Mathematics, a Complete Course, with CSEC questions by Raymond Tulsi, that is with CSEC questions by Raymond Tulsi. And this is a picture of Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like. This is the home page of that website. You would have to register first, and of course, subsequent to that, sign in. Remember, I said it is free. This is that URL again. I will include this URL in the description of this video below, so you can easily click on it and be redirected to this website. A reminder that this formula sheet you see on the left here is provided for CSEC math examination papers, papers 1, 2, and 3. This formula sheet is included in a full copy of the syllabus. There will be a link in the description below from where this formula sheet can be downloaded in case you don't have a full copy of the syllabus. This is the top part of that formula sheet, so you could see it a little better. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are here, section 8, geometry and trigonometry. This is a print screen from the first page of the objectives for this section. Those have all been completed. This objective 3 in 4 parts, that as well. Objective 5 has been completed. Everything you see here is one objective. Objective 6 has been completed. Everything you see here is one objective. We are now at objective 7, which is video 14. You will notice that all of these objectives on this page, right down to objective 11, they deal with transformations. So for the next few videos, that is all we will be talking about, beginning right now with translation transformation. And then this section goes up to objective 17. As I said before, all of those are completed. These 4 have been published in their entirety, the others partially. We are here, objective 8_7. This is video 14. When this video is finished, it will be partially published on YouTube. Projection for the rest of this section. These other 4 videos will be published on YouTube in their entirety and the rest partially. So let's get back to objective 7, video 14. It says, represent translations in a plane using vectors, and the type of vector is a column matrix vector, which looks like this, xy in square brackets. Now recall in objective 8.4, when we were talking about type of symmetry, we already talked about one type of symmetry known as translational symmetry, where you slide a figure a certain distance along a line in a specific direction and it keeps everything unchanged. For example, now remember this is review. If you take this object here and you take that midpoint A and you slide the whole object over here, so it becomes this, that is called translation symmetry. Every aspect has a one-to-one mapping. Recall still that in this video here, we talked about translate, and your syllabus mentioned something about tessellation, which we are not really using in this syllabus. We are, however, using translation. So we will stick with translation. And if you can't remember what we said about tessellation, go back to objective 8_4. This is the tessellation. Remember also we said if you could move that multicolored hexagon from A to B, that amount in that direction, you could also move it in another direction, this amount. And so, how many such points in distance and direction can exist? And the answer is, we already dealt with this, an infinite number of translation symmetry we can get. Now in objective 8_7, we have to represent translations in a plane using vectors. Now we are dealing with transformation, not symmetry. That is to say, how far and in what direction, since a vector has both magnitude and direction. So now we are going to be a little more specific in translation when compared with symmetry. And we will be using the column matrix format as required by the syllabus. In this objective 7 and the next 4 objectives, as I said before, we will be dealing with transformations. Now there are 6 types of transformations: translation, reflection, rotation, enlargement. Now there is also shear and stretch, but you don't have to do these 2 for CSEC. Those 2 are not required. In this objective, we will do this one. And in the next objective, we will deal with the other 3. So let's come back to translation. It is a rigid motion of the plane or space of the form x goes to x plus v for a fixed vector. If you don't understand that, don't let it bother you. You will understand it by the time we get through with this video. Now, there are 2 types of quantities. If you are doing physics, you have to know this. You don't have to know this for math. One quantity is called scalars. These are quantities that have magnitude only. Example, you could say a distance of 4 meters, or you could say a speed of 25 meters per second, or you could say a mass of 45 kilograms. Those have only magnitude. As opposed to vectors, which have magnitude and direction. Now, instead of saying distance, if you have a direction, you would have to say a displacement of 4 meters due east. And instead of saying a speed of 25 meters per second, if you have a direction, you say a velocity of 25 meters per second at a bearing of 0.45. And instead of saying a mass of 45 kilograms, you now have to say a weight of 450 newtons, because you just multiplied the kilogram by 10 for gravity, which is always downwards. It has direction. Now, some ways to express vectors, if you have a grid like this, is to draw an arrow whose length represents the magnitude and its direction represents the direction of the vector. For example, this arrow here could represent a vector, both in terms of magnitude and direction or that arrow. Those are two identical vectors. Doesn't matter where you start, here or there. They have the same magnitude and the same direction. Point of origin does not matter. Now that's one way to express a vector. A second way is to use a lowercase letter with an arrow above it and the magnitude. It doesn't tell you what direction. It just says a vector v of 11.2 centimeters. You know it's a vector, but you don't know which direction. A third way is to use a lowercase letter with an arrow above it and parenthesis, like the vector v 10, 5. Now this is not a coordinate, and I will explain that as we go along, which now leads us into the fourth one that we are concerned about, column matrix. The vector v is represented by the column matrix 10, 5, and it's in square brackets. Now notice that this here is not much different from that, except that it's organized differently, and you may mistake that for a coordinate. Whereas in this case, it is not a coordinate. You cannot mix it up and say that's a coordinate, 10, 5. No. Now what this 10, 5 means, it is plus 10 units horizontal and plus 5 units vertical. So if you begin here, you go 10 units that way and 5 units that way, plus 10 and plus 5. Of course, if those were minus units, negative units, you would go negative 10 that way and negative 5 this way. So this is the one that CSEC wants us to use, which we will learn about in this video. So you already know that if this is a number line, this direction is positive, that direction is negative. And if this vertical line here is a number line, that one there is positive and this side is negative. Another way to think of it is that if you stand here with the rising sun on your right, that direction is east, and of course on your left, that direction is west. You will be facing north, and behind you is south. And we will be using these concepts as we go along. Note the top number represents x. If it is positive, move that many units to the right, which is the east direction. So this 10 here represents x. It's a positive 10. So you would go in this direction from wherever you start, not to the coordinate 10, 5, but from wherever you start, you will go 10 units this way, positive 10. Of course, if it was a negative 10 and you start here, you will go 10 units that way, negative 10. Negative 10, which is west. Note also that the below number represents y. This 5 here represents y. If positive, move that many units up towards the north. And if negative, move that many units down towards the south. So let us take an object here, and we are going to translate it using this column matrix vector. You can do two things with this. We can take a point here. We move it 10 to the right because it's positive 10, and then we move it 5 up because it's positive 5, and so we have to slide that whole object this way so that this point here arrives here. Now we got that from the graph, which is 5, 7, but we can calculate that, as you will find out in a little while. So that's the image.